All right, here we go. Another lesson on multiplying polynomials this time. So last time we added and subtracted polynomials. This time we are going to be multiplying polynomials. And if you remember the product rule from last week, then this is the product rule on steroids, because we're just going to do it a whole bunch of times. And we're going to combine like terms then if we need to. So that's the only addition to the product rule, is that we're going to be combining like terms if necessary, in addition to the product rule. Okay, so the product rule says we multiply variables that are the same, and when they're the same, we add their exponents. And if they have a coefficient on them, we multiply the coefficients together. So did I say that right? We add the exponents and we multiply the coefficients. Okay, so here we go. In this first one, we have 6x times 4x. So the coefficients are 6 and 4. 6 times 4 is 24. And the x's have 1s on them, so it's x squared. Okay, so simple enough. That's about as simple as we can get. And that's basically the product rule. And another way we refer to that is multiplying monomials, because a monomial is a single term. So 6x is a monomial. 4x is a monomial. Mono means one, so that's why we call them monomials. The second one, again, they're monomials. Negative 7x squared is a monomial. 0.2x to the fifth is a monomial. If you say monomial over and over again, it starts to sound kind of weird, but that's just the way it is. Okay, so negative 7 times 0.2 is negative 1.4. And then x squared, x to the fifth, that's x to the seventh. All right, fractions, of course, they're going to throw a fraction at us. They're both negative. So the key thing here is whenever these two things are negative, we know our answer is going to be positive. So that's one thing we know for sure. So we have a positive answer, but when we multiply these, we're going to multiply the numerators. So 1 times 2 is 2. 3 times 9 is 27. And then we have an x to the fifth and an x to the 1, so that's x to the sixth. Okay, and if you were in class last week, you will remember that I showed you multiple ways we could write this. So 2 over 27 times x to the sixth means that x to the sixth is in the numerator, so we could also write it as 2x to the sixth over 27. Okay, so both of these are the same thing. All right, here we go. Distributive property to multiply polynomials. All right, so here we go. A little bit of product rule on steroids, but not too bad yet, because we're just multiplying one thing by the two things on the inside. Now, if you remember from intermediate algebra, your teacher may have shown you how to do something like this, where we take something like that, and we put the 2x to the third up on top and 6. Now, some of you might be saying, oh, it's the lattice method. Well, it's similar. It's not quite the same as the lattice method. So now what we write in the boxes, I can switch colors, watch. So what we write in the boxes is the result of multiplying monomials now. So I'm going to multiply the 5x times the 2x to the third, and I get 10x to the fourth. Some of you might be thinking, wait a minute, last lesson we didn't combine things that had different exponents. Well, we're not adding and subtracting, we're multiplying now. So that's a totally different game. Okay, so then 5x times 6 is 30x. And then we want to write our answer as these two things added together, but we can't combine them together, so we just write them as a polynomial. So a polynomial, poly means multi, so it has multiple terms. So in this case it has 2, so we have 10x to the fourth, and since it's positive 30x, we're going to write plus 30x. Okay, so I love this little box method. You may be like, nope, I don't like the box method. I just want to do the rainbow thing where I draw the big old arcs, but that's perfectly fine. Whatever method works best for you. But this box method works well for me because it really does a great job of helping you stay organized. All right, and now we have a monomial times a polynomial with 3 terms, and the only difference with a polynomial with 3 terms, if we're going to use the box method, is we need 3 boxes. So we have negative 3x squared. And so then we have more boxes. So we have 5x squared, 6x. And now notice how I didn't write the plus 6x because it's positive. I'm just going to write it as a positive 6x. But this minus 1, one of the big mistakes we see is people just write a 1. But they forget that that minus sign makes that a negative 1. So I'm going to write it as a negative 1. Then I'm going to switch colors. So then negative 3 times 5, so we have negative 15 x to the 4th. And then we have negative 18 x to the 3rd. And then we have negative times negative is positive, so it's 3x squared. So in this case, we have negative 15x to the 4th minus 18x to the 3rd. And then that's positive 3x, so I'm going to write a plus sign, plus 3x squared. Not too bad. All right. Oh boy. Here we go. 3 more. We can do it. Okay, so multiplying binomials. You might remember from a long time ago something called FOIL. If not, that's okay. First, outside, inside, last. So we multiply the first terms together, the outside terms together, the inside terms together, and then the last terms. But that's kind of a easy way to maybe skip something or get confused. Who knows? So again, I like to use the box. So let's do the box. You may be like, I'm tired of the box, but I like it. It works well. So in this case, we have 2 binomials. So these are binomials. Bi means 2. So there's 2 terms in each one. The 3x is one term. The 2 is another term. The 2x is one term. The negative 5 is another term. So we can put those binomials wherever we want. So I could put the 3x and the 2 on the top or down the side. It doesn't matter. As long as I don't put the 3x on the top and the 2 on the side. I want to keep them together. So they're together. And then we have 2x. Actually, this works well because it's easier to see that's a negative 5 now. So if we switch to our, so we have 6x squared. The squared is one thing people forget a lot. So don't forget, x times x is x squared. And then we have 2 times 2 is 4. So that's 4x. Then down here we have negative 15x. And down here we have negative 10. And this is one where we end up, I can use a highlighter, being able to combine these two because they're both x terms. All right, so my answer in this case is 6x squared. And then negative 15 plus 4 is negative 11x, and then minus 10. Okay, so the biggest mistake you are going to make as you're going through this is you are going to try and go too fast. And you're going to look at negative 15x and 4x and call it negative 19x. That's going to be a common mistake. So be careful. Don't make that common mistake. All right. From a couple lessons ago, we learned something about exponents. That exponents mean multiply something by itself. So what we can do is write this out. We're going to multiply that thing by itself. So the exponent is on everything in the parentheses, so I'm going to multiply it by itself. So now I have 2 binomials. So I can do the box method again, right? Now there is kind of a trick to doing this without the box method that you can do it pretty quickly, but let's just keep it simple here. Well, that needs to be bigger. All right. So here we go. Oh, I want to say blue. So they're both the same. 2x negative y, 2x negative y. So when we multiply things here, 4x squared negative. Now watch. I'm going to write the y second. We always seem to want to write it xy, alphabetical order, right? Negative 2xy. This one's the same, negative 2xy. And then negative times negative is positive, so this is just y squared. Okay, so again, we got some stuff on the diagonal there we can combine. So we have 4x squared minus 4xy. Okay, so this is, I guess I haven't mentioned this yet, but when we're multiplying polynomials, we have to kind of switch back and forth between this idea of adding exponents and just multiplying coefficients and keeping the, or sorry, just adding coefficients and keeping the exponents the same. So in this case, what I just combined in the highlighted green, I didn't change the exponents at all. They stayed the same. The only thing that changed was the coefficient. Okay, so that's something to think about. We kind of have to switch gears when we're thinking. And then the last thing is just plus y squared. All right, 2 more. In this case, you're thinking, finally, this is one where you can't use the box. Wrong. I can use the box, and I'm going to because I like it. It works well. So here we go. But I'm just going to make the box wider. And I'm going to divide it in half this way and thirds this way. So look at that. So this forces me now to put the t plus 2 on the side. I didn't write the plus 2 because it's positive 2. We can all see it's a positive 2, right? And then 3t squared, negative 4t, and positive 2. Negative 4t, not 40. Careful how fast you say that. Okay, so we have 3t to the third, 6t squared, negative 4t squared. Oh, that's kind of messy. I gotta make a smaller negative sign. Negative 4t squared, 2t. Then we have negative 8t and 4. Now this one, if things are in the right order here, and they are, so like I said last lesson, things go from largest to smallest exponent. This is where it's really important to go in that order, because if it's in that order, then generally speaking, we're going to be able to combine things that are on the diagonal. So I can combine those two, and let's see here, I can combine these two. Okay, so now when I combine, I have 3t to the third plus 2t squared minus 6t and then plus 4. Yeah, all right. So multiple combining like terms. And now using this box method, it really highlights easily what needs to be combined. If you didn't do the box method, you're going to have 6 terms that are going all across, and you just have to look through them all and say, okay, what's the same? Are there any that are the same? And it's not impossible, but not as well organized as this by any means. All right, here we go, another one. I'm going to do it. Yeah, I'm going to do the box. All right, so we have y and 2. This is almost the same. 3y squared, negative 4y, 1. And then I'm going to go through and do my multiplying. So I have 3y to the third. This is like very similar. 6y squared, negative 4y squared, negative 8y. Y, I don't need to write the 1. You know what, I can, because it'll make it easier to combine like terms. And then we have a 2. Okay, so if we highlight, we've got those, and we've got, ooh, that's really bright, those. Okay, so if we combine, I'm going to do it down on the bottom here so there's more room. 3y to the third. 6 minus 4 is 2, so that's 2y squared. Negative 8 plus 1 is negative 7. Negative 7y, and then 2. And you'll notice 3, 2, 1, no exponent. So the exponents all go in order. All right, again, evens, odds, odds, odds. Don't do everything, and don't just do 2 and 8. You got to do 6, 4 and 6 as well, right? So make sure you do the evens in between, the odds in between. Yeah.